My name is Julie Sparks. I am a security engineer, and I'm going to talk to you guys for the next 60 to 90 minutes about how to build security detections, which is often called detection engineering. So since this is a long talk, I wanted to split it up into different sections and then add some question breaks in between. So I'm going to talk a little bit about me, go through kind of a crash course in security detection writing, and then we're going to walk through some scenarios, and I'm going to give you guys some chance to look at logs and detection frameworks, and then we'll evaluate what we've written, revise it, and then talk about how to integrate it into a larger system. I'm going to stop for questions after the crash course in security detection writing, after the portion where we're doing hands-on work, and then at the end for general questions. So that's the chance if you want to add questions to the chat. I'll take stops there to read them and kind of give you some feedback. In general, I'm going to be asking a lot of open-ended questions and doing some polls, so I'd appreciate people's participation in the chat. Even if you're guessing and you just kind of have an idea, like feel free to throw it in there. Cool. So a little bit about me. As I said, I'm a security engineer at Cloudflare. I work in the detection and response team, which has the word detection in it. So I'll get into a little bit more about what I do. I've been at Cloudflare for about a year. In that time, I've really enjoyed the security detection aspect of it. In the past, I've worked in different kind of security areas, and this one so far is my favorite. I'm originally from the East Coast, but about 8 months ago, my partner and I moved to Denver with our cat, and we're actually getting a puppy soon. So we really enjoy Denver, and yeah, we'll be here for the foreseeable future. In general, I'm just obsessed with reading, learning new things, and recipes. COVID's given me the time to cook an obscene amount. This is basically how I spend my day when I'm not doing security things. Before I dive into the crash course in security detection writing, I wanted to walk through some definitions and concepts that I'll reference when I'm talking. I'm unsure if you guys are on the beginner level or the intermediate, but I want to make sure that when I'm saying things and throwing out acronyms that you're not completely confused. For people who are newer, I think the terms that are most confusing are the acronyms. So I'll let you guys read this general slide, but I'll go over the SOAR, which is a security orchestration automation and response. Basically, this is a tool that you can use to help you automate incident response. So maybe when there's an incident, you need to quickly be able to suspend someone's account. This is the tool that you would use. For SIM or SIEM, people pronounce it differently. In general, you can think of it as a place where logs are aggregated. So you have a ton of data, and then you can do searching and detection writing on top of all those logs that you're collecting. I also threw in GCP, which I'll reference on and off because it stands for Google Cloud Platform, and that's actually where we at Cloudflare have our logs. So that's what I'm most familiar with. And then in general, detection or rule are kind of, people use them interchangeably, but a detection is logic or a function that matches on a specific pattern. So we're going to be talking about how to apply that in the security realm. So I'm on the detection and response team, and I'm in the blue team track. So I kind of just wanted to talk about what a detection and response team is. We are similar to blue teams, and we're kind of a hybrid model where we spend a portion of our time doing investigations, incident response, and then we spend another portion of our time doing engineering work and security detection writing. So that includes everything from the internal tooling that we use for incident response, all the way to walking through threat research, thinking of scenarios that can happen, and then writing security detections that will alert us if that behavior is detected in our environment. If you're unfamiliar with blue teams, you'll also see teams that are called security operations teams, threat research teams, security detection engineering, security tooling, computer security incident response. All of those, we like do similar functions. It's just kind of slightly different scopes, and it depends on the type of organization you're at. So now is when I get into my security detection crash course. Just as a reminder, if any of these slides you have questions on, add them into the chat, and then I'll walk through any of the questions when I finish up. So at the end of the day, what is the purpose of you writing a security detection? So you want to be able to catch the bad things or things that you think are signs of suspicious behavior, but you don't want to get alerted on every good thing that happens. So every time an employee logs in, that's fine. You don't want to get an alert for that. But if an attacker logs in, that's a pattern that you want to know, you want to be able to alert on. The other hand of every security detection is that you want incredibly low false positive rates. False positives are alerts that trigger, but they're not actually suspicious behavior, bad things, abnormal. You don't want to constantly get alerted on that behavior, because then all of your time is going to be spent looking into things that are not actual patterns of malicious behavior. So I'll get into how you can kind of tune that down and make sure that the detections you're writing do not have high false positive rates, and they're not gonna burn out your team. So in general, this is the steps that I go through when I'm writing a security detection. So first, I determine what I have to work with. Not every team has every resource. So you have to sit down and think about what logs you have available to you, what tools do you currently have available to you, and from that, what do you want to prioritize? So what part of that data do you want to look at first? Then I evaluate what threat do I want to detect. So there is a million threats out there. What do I think is most important for me to be sitting down and looking at, given the resources that I have? This is where you can kind of think and do some threat research on a specific scenario that you think might apply to your environment. So is there a process that you think could be exploited? Do you have some logs connected to it that you can dive into? Once you've been thinking about those questions, you have your logs, you kind of know what you generally want to look for. You begin researching the threat and trying to understand how that threat will occur in your environment so that you can write logic that would detect that pattern. During my research, I'll go through hundreds of logs to better understand what is typical behavior. As a security engineer, I don't always know what that is. I'm not the person that built the system. I'm not the person that maintained the system. So I need to spend a good amount of time trying to understand that system, how it's configured, so that I can write a good detection for it, and I'm not writing logic that detects a pattern that is completely intended by the people who built the system. Next, I'll build the logic by either filtering for certain event types or writing a query that can pull fields over a specific period of time. So I want to say historically, has this happened? Is this pattern rare? Is there going to be a lot of alerts that go off if I write this detection? Or has it never occurred? And then I need to try to figure out if there's a way that I can cause that event to occur so I can make sure that the logic I'm looking at would accurately detect that pattern. Oftentimes, my investigation doesn't turn up any malicious behavior, which is obviously, as someone on the incident response team, you don't want to find malicious behavior. Hopefully, everything's running smoothly. But when you're writing detections, you do want to kind of find those abnormal patterns, because that's giving you the context for the detection that you're trying to write, the behavior you're trying to dive into. So then you have to determine if you don't find that malicious behavior based on the pattern you're trying to look for. Was it an incorrect hypothesis on your end? So did the logic you build not actually identify the behavior? Or is it because you just simply don't have the data, like that event has never happened? So you go through this iterative process of continuing to test your hypothesis, trying to figure out if the data is right, if you need to find a way to replicate that malicious behavior in your environment so then you can further test on it. And then the last step I like to go through is the next steps. So just because you spent all this time diving into a potential threat scenario and you have logic and you're 99% sure that it's going to check that bad behavior, there are additional steps where you have to go through peer review. You should talk to the system owners. You should really understand the impact that building that detection has in your greater environment. A framework that a lot of people like to use is the MITRE ATT&CK framework. This will give you an idea of what area that detection is addressing, and if you have other gaps that you need to then focus on next in order to have just a good overview of if that malicious thing were to happen, you would have a way to detect that and respond. People also often use like the last step to give the detection a severity score. So like, how severe is it if this detection matches on a pattern? And that will give the people who are responding to the incident a better idea of is this like, do I need to wake up in the middle of the night to respond to this? Or is this something that can like go a week and I can check it when I have extra time? The peer review is also often like a really valuable step because you can't write detections alone in a silo, and you need to be able to get the feedback of other people on the team who might know something that you've missed or have better insight on the system that you're writing a detection for. That being said, what could you write a security detection on? Really anything that produces logs and that you could imagine a malicious scenario occurring, which in my world is basically anything. Some examples of things you might be familiar with are internal network traffic logs, so network logs that occur in a corporate environment, administrative logs to like a corporate Outlook account. So basically all these logins to admin portals are really interesting. Employee access to SaaS resources. So as people move to having everything in the cloud, you are relying on the logs of that cloud provider to understand what your employees are doing in that resource, whether it is like an HR portal, whether it has something to do with sensitive customer data. All these things are really important to think about. And if it's in the cloud, you aren't hosting the system. So you really need to be able to understand it and make sure that you have logs for it and detections. So SaaS resources entirely are like a really interesting thing to dive into with detection writing. And last one I'll mention as an example is processes on corporate endpoints. So processes that are executed on company laptops or other company devices, and understanding, is that like a sign of malware? Is that process something that shouldn't be occurring on employee laptops? Being able to look at those logs and like dive into them. So in my mind, there's three types of detection rules that you can write. There are single events. These are, or they're also called simple events. But this is when you write a rule that detects a specific event type. So you don't need to worry about state. You don't need to worry about events that have come before or after it. You are looking for one specific pattern, and every time it occurs, you want to trigger a response. So for example, this could be if someone from your company logs in from Russia and you don't have a Russia office. So you would say every time this occurs, it doesn't matter what came before or what came after, I want to trigger an alert. So that would be an example of like a simple or signal event. And then you have multiple events or composite events. And these are when you're looking at a series of events. So you would want a composite rule in order to join two or more simple rules, which sounds very complex. The easiest way to think about this is like you want to write a detection that looks at events that have happened over time. So you don't want to get an alert if someone is trying to log in and they get a failed login attempt. But if the same person has had 10 failed login attempts in like 30 minutes, then you could say maybe someone's trying to brute force that account. However, you can't detect on that behavior by looking at a single event. You have to look at a series of events to understand that behavior and make that pattern. The third one that I'll mention, which is a bit outside the scope of this talk, is machine learning models. Security teams are moving towards this model a lot. It's very complicated, but the idea is that you could have enough resources that you would build models that would work as detections. So you'd be able to profile a user or asset behavior, and then you can trigger alerts when that deviates. So instead of knowing exactly what pattern you need to look for, it's easier and harder to build in the fact that the model will tell you that it's an abnormal pattern without you having to write the logic for the pattern yourself. And so this becomes very valuable when you're looking at large scale things, and especially things that change often, and you don't have these security engineers to keep changing the detections to kind of tailor it to new scenarios. To go through some extra examples, just to illustrate some of these points and have you in the security detection mindset. A single event you could think of is if a zip file is attached to an email, then trigger an alert. Obviously, this alert would be incredibly noisy. It's not something you would want to actually implement, but it shows you that you're thinking, oh, if someone zips a file from their computer and emails it, that's an event I can detect on. And also that could be an event that signifies data exfiltration. right? So if someone at the company is sending large files and they shouldn't be, then that's something that maybe the security team wants to look into. An example of a multiple event detection would, again, be the one I mentioned before. If there's several authentication attempts, and this one is to the same computer, but in the same IP address with different usernames, and trigger an alert. So there's a bunch of ones that you can think of over time to kind of build that pattern and then give you better insight into what's actually happening. The machine learning model, a user logs in remotely at 3 a.m., usually only doing so locally during normal business hours, and then makes repeated attempts to connect to a production database as an administrator. So you might see this and think, well, this is multiple events over time, so could you write a composite detection over it? Yes, but it would be very hard because keeping state on every single employee in the company, imagine if you have 5,000 employees, becomes incredibly difficult. And the best way to do this without dedicating a ton of human time to it is via a machine learning model. So I'll take a minute to talk about, so correlation rules would be the composite rules I was talking about versus machine learning models. And so when you're building detection rules, you have to understand the limits and the benefits of using each of these. So correlation rules are best for like when you know what the threat is, and you know what the pattern is going to be, you know what the IP address might be, and you can build a very specific detection. It's also really great if you know the signature of the threat, and you can incorporate that into the detection. It's also really great for knowing compliance or policy violations because those are very specific things. So you know what people should or should not be accessing. So you can look for that access pattern and then build a detection. However, if you're thinking about things that are more vague, more behavior-based, very ambiguous about what someone's supposed to be doing, this is when machine learning models can be really helpful. So for example, a data exfiltration or insider threat, machine learning models are one of the few ways you can be more sure that that is actually occurring versus that is something that someone's job responsibility requires. So I would say for our session, we're talking about single and multiple event rules, but machine learning models are kind of where people are moving to for more complex problems that they're trying to solve, and you'll see more of it as kind of the security detection engineering field matures. So I wanted to go over some of the common detection writing tools, frameworks that you probably have heard of if you've spent like any time in like incident response. You have Sigma, which is a detection framework that you can use to basically write detection logic on any log file. It's an open source tool, all these are. Yara is the most popular one for endpoint logs. So think of trying to write a detection for malware on endpoint processes. Yara is the most common. And then Snort is really well known for network traffic logs. Endpoint and network logs are like dramatically different than kind of the generic log files that you would get from like your cloud environment or your email provider or like Salesforce or your HR system. So Sigma is kind of like the one that can fit all of the use cases, and then Yara and Snort are like a bit more specialized to that area. So I wanted to stop and see if folks had any questions. I see Wendy asked one. Do you use EUBA tools and feed logs into a machine learning model? So EUBA is end user behavior analysis tools. So Wendy, to your point, we are working on this. We don't have anything that's like fully in production, but we're currently training and testing machine learning models because we want to get to the point where we can use those, especially for use cases that the simple and multiple events just like don't really make any sense for the patterns we're trying to detect. So a lot of like data exfiltration, insider threat approaches, and then logs that are a lot harder to find specific patterns on. So for example, Google Drive logs are pretty complex and they have like a ton of different patterns and possibilities with them. So being able to understand like end user behavior in Google Drive, what they should be viewing, what they shouldn't be viewing, what should be shared externally, what shouldn't be shared externally. Those are the kind of problems where we're currently like trying to develop good machine learning models that we can bring into our like incident response cycle. Or does anyone else have any questions? Yeah, of course, Wendy. Cool. I will keep going, but if people have questions, definitely add them in the chat. So this is a section where I wanted to get as quick as possible into the part where you all can look at some logs and look at some detection formatting. I've added some links in the chat. There's 2 code sharing links. One of them is a link of different Okta logs, one that I'll be going through in a scenario, and then 3 more example ones that you can take a look at. The second code sharing link is an example Sigma rule. So we're going to focus on Sigma for this workshop. And there's an example rule that we're going to be filling out in the scenario. So if everyone can open those, and then we can start adding them together. If anyone has any problems viewing them, please let me know. It worked fine for me, so I'm hoping that it works fine for everyone else. All right. So as I said, in kind of the steps that I go through, the first thing I think about is evaluating the data I have. So which logs do I have access to? Do I have access to endpoint logs, application logs, like the SaaS logs I was talking about, network logs, or just miscellaneous ones that maybe internal tools produce? And then once I have a list of the logs I know I have access to, which of those systems should be prioritized? So which is the highest risk? For this example, I'm going to focus on Okta logs. And Okta, in my mind, is one of the highest risks because it's a system that people initially log into. And for people who don't know, Okta is an identity platform that many companies use for single sign-on and then authenticating their users. So it's a great log resource because it will show every login event to an internal system and lots of context information attached to that event. So you can really understand like what they're doing, what's going on, the IP address, geographic information, and then all the accesses that that user does to different applications. So every time they go to a new application, they'll authenticate to it. And that log will be produced and available to the administrator. So I've grabbed a sample Okta log. This is the same one that's in the code sharing, the code sharing link in the first one. And so looking at this log, for me, this is very exciting. For people who are not really into security detection, it's a lot of fields to look at. I would say you can automatically identify like the fields that are most important to you, right? You want to know who is the person that took the action. So in this case, it's Kyle Diedrich. You want to know when he logged in and from where. So you see the IP address here, and there's also a timestamp, which I believe I cut off in this screenshot. For those of you who are familiar with the MITRE attack framework, these login events are really helpful for diving into the initial access scenarios where you're wanting to know if an attacker has gained access to an account. As soon as an attacker logs into something, there should be a login log. And so you can look at that behavior or that pattern when they're logging in, and if it differs from the expected behavior that you believe the employee should have taken. So based on the data that I showed in the Okta log, we have to think through what threat could be detected, and then whether you're focusing on a potential internal or external attack. So internal insider threat, external attack, someone who you don't know, an external attacker who has gained access to the system. And so in this case, with the Okta log, I'm focusing on initial access via a trusted relationship or a valid account because I see a valid employee has logged in to Okta. I saw his email address, and so I know that's a real account. Another option is trusted relationship, which is what I'll dive into a second. But if you want to drill down into the different threat scenarios that are possible, I highly recommend the MITRE attack framework, which is linked here. Another way to kind of get ideas on different like threat scenarios to look at in your own environment is to go through security conferences and blog posts where researchers speak about new vectors that are being exploited. Other security engineers talk about things they're looking for in their environments. For example, maybe there's a new Salesforce vulnerability or a new variant of malware, and you want to be able to build detection rules internally. So based on the attack scenario that you choose, do you have the ability to reproduce it? And so this is what I was saying, when you build a logic, you also have to keep in mind what you can test. And if you're able to, maybe you're willing to take the chance of putting a detection to production that actually has never been fully tested. However, that's not ideal, right? You want to be able to know that if that behavior occurs, your detection is going to send an alert to the incident response team. Another thing to think about is if you have enough signals to be able to write the detection logic. So for an example, like some logs don't have geographic context. So they don't have the country, the city, any of that information. Some don't provide user agent. These are things to think about when you're looking at a log source and trying to write a detection. If the detection you want to write is based on a behavior where you need to know the geographic location, but you have no way of getting that information from the log, then it severely limits what you're able to do. In our example with the Okta log, I'm going to take a look at raw user count and the user count to determine, or sorry, raw user agent and user count to determine if an automated service is taking actions through a user account instead of a service account. So I'm going to, give me 1 second, I'm going to switch tabs. And show you, so this is what you should be seeing if you open the code sharing links. But I'm going to take a look at this log and kind of show you all the things that are red flags for me and things that I would look for when writing a detection. So the first thing I brought up was the raw user agent. Right here, you see that the user agent is Postman Runtime, which is an automation framework for API calling. This is a red flag to me because it appears that this user is an employee at the company. This doesn't appear to be an IT service account or an engineering service account, and yet there is an automation using his account to log into things. So whether this is a malicious actor or whether this is a policy violation, that's kind of the hard part to tell just from this log. But those are things that are red flags to me. And then I look at the IP address. Okta gives you the geographical context. It was from San Francisco, United States. Those things are fine for me from just a geographical context perspective. The next thing I would look at is go back to his other logs and try to see if this IP address is consistent. How often is this Postman Runtime user agent using his account to log in? Is this behavior that I expect? And then you're able to see like more information on the event that they took and whether it was successful. So Okta, as with many logs, they produce a log every time an action was taken. So this could include if the result is a failed attempt, which obviously you don't want to detect on failed. So this is one of the things where you have to look through the entire log and understand every part of it so that you can make sure that you're filtering on the appropriate things so you don't get like a ton of noise or you get alerted when there's an attempt that actually never actually occurred and was blocked immediately. But those are some things to think about. Let me go back. To your presentation. So when you're actually going to write the detection logic, you want to know what behaviors are indicators of the threat you want to alert on. And then you're going to try to like create the detection based on the logic you think would occur, and then write that into the format that you want. So for this case, we're doing Sigma. If you're doing an endpoint threat, that might be Yara. If you're doing something in the network, that might be Snort, or any of the proprietary detection writing languages that occur with a variety of SIMs that you can purchase. So as I highlighted when I shared my screen, things that stuck out to me were the fact that this is an employee who's using his account to log in, or letting an automation use his account to log in. So this is just pseudocoding it, like the actual syntax depends on your specific tool. But here I say, if the event alternative ID, which is his email, does not include service, which maybe service is the way that you denote whether it's a service account, and the raw user agent includes Postman, which we know is an automation, then we want to alert on that. And this is a very simple single event alert, but it kind of gives you the idea of these are all just logic statements that are tied together based on timeframes and different characteristics that are available in the log itself. And so if you open the code sharing link I gave for the Sigma detection rule template, you can see basically the first one is just a template of a example Sigma YAML file where you can add in like title, ID, the status, description, author, date, and then the log source detection. And then once in the alert field, you see the ability to add a playbook, policies, and determine a severity. The one thing I'll call out from this is that the dedupe field is really important with detection writing. This is the field where you want to say, if an event happens, so if this person has Postman log into his account 3 times in the same 5 minutes, I just want to get alert on the first event, right? So create an alert type for this person, Kyle Diedrich. But if this occurs again and again and again, do not create duplicate alerts, which is really vital. And you need to make sure that you have when you're making the detection, understand what events you want multiple alerts for. So maybe if I want to dedupe by the raw user agent, so I want to know if there's a different type of Postman automation that runs on his account, but it's the same person in the same 5 minutes. Whereas if I deduped on just his email, I would only see one event for one use of Postman, which is a very nuanced example, but there's many ways to think about this, and it changes the amount of alerts that are being generated depending on the detection itself. If you also look at that code sharing link again with the Sigma template, the second Sigma excerpt is an example of the detection that I was just talking through with the raw user agent being Postman and the email account not being a service email account. And it kind of shows an example of filling that in for a simple event type. So I want to talk about, once you create this detection, how would you go through and evaluate whether it works well, and how would you revise it to be a bit better? Just like with regular code or even just writing, sometimes you create something and it's definitely not what you anticipated, and you want to be able to take time to go through and make it so it detects on something a little bit more granular, is less noisy, or uses better characteristics to make that decision. So if you're running your newly written detection in a testing environment, does it detect the behavior that you wanted it to? So that's the first step. If it doesn't detect the behavior you wanted it to, then you need to go back and look at the logic you wrote and see what the issue is with it not being able to pick up that pattern. The second thing you want to look at is, are there any false positives? So is there behavior that's being detected that you did not anticipate, but is actually legitimate behavior you do not want an alert on? And so then this is the really helpful part of testing it. You can look at these false positives and kind of compare them to the scenario that you thought was going to occur. And you can look at the differences and determine, is this a scenario one where I think needs to become a separate detection, or can I find a way to further refine it and make it more granular, more specific to the situation that I'm looking at, and then I'll handle maybe another scenario that popped up with another detection. You can also look at what can be improved. So if you're getting a ton of alerts from this detection, within every hour you're getting 10 alerts, That's obviously way too many, depending on your size, I suppose. If you're a really big company, maybe that's the amount that you anticipate. But if you're a smaller company, that is way too many for the amount of people you have on your security team. What can you write? What can you create with that detection to make sure that level of noise is lower? And at the end of the day, if you have a very noisy alert, people are just going to start ignoring it. So you make sure that you take the time to make it as low noise as possible, so that's actually adopted by the incident response team and actually provides value for them. An example scenario that I want to talk about that you might find when you're testing your detection is, let's say the IT department has several old user accounts that act as service accounts, and these create false positives. So every new application that needs a service account gets one. However, you have these 3 people who are the founders who still use their user accounts to run a ton of automations on. So then you have to think about, how do you want to handle this? Do you want to create an allow list where you let those accounts be used as service accounts? Do you ask IT to migrate everything over? How much burden is that going to be for the IT department? Is there a policy that comes into play? So you have to kind of make those decisions that actually like go outside of just pure detection logic writing, because these are the nuances of modern company environments. They have a lot of things that you don't expect until you start trying to dig into the logs and write detections on it. So once you finish testing the detection and you think it's ready to go, you need to document all the research that you've been doing, all the testing, and then be able to pass it on to your teammates for peer feedback. Detections cannot be written in silos because they're not meant to be used by just one person. It's really, really important to have other people look at them, give their opinion. Oftentimes they'll know certain things that you don't. They talk to a certain system owner. They know how things are configured. And so they can give you feedback on how to make that detection logic even better. Writing a playbook is the almost most important step, I would say. Like, the logic is the most important, then the playbook, because the playbook is what the incident responder is going to use the moment that detection creates an alert. And so if you create a detection but you have no playbook, you're basically paralyzing your incident responders because they have nothing to use in order to solve that alert and be able to remediate it. So based on all of your research, your testing, and your deep understanding of this detection and what behavior it's supposed to catch, you have to write a playbook and then follow it up with specific actions that can be taken to investigate the alert. And the last step you can take is, based on those specific actions you write in your playbook, can any of those be automated so that the response for the person who's on call is even faster and takes less time on their end? This is a step that when I first started working on detections, we weren't mature enough to do. But now that we're getting to this point, it's really, really helpful, because if you're handling a large incident, at the end of the day, if there's a small detection, like a detection that gets fired, that's going to be the least of your priority, because your hands, like just spending all your time focusing on this huge incident. And the last thing you want to do is respond to an alert that got fired by an internal detection. And so if you can automate that entire process, that's amazing. No one that's on call has to deal with it. Or you can try to automate pieces of it so that when the on-call person can finally spend time looking at it and trying to respond, they already have all the pieces they need to be able to respond to it incredibly quickly. And that's when you'll get really high adoption, and people will feel like the detection isn't becoming so overwhelming. It's actually providing value to them, and that it's an easy part of their daily process. So this is what I want everyone's input. And so I shared people with those links, and I really want to talk through some of the detection logic that you think could be useful. So there's 3 octalogs, or you can talk about a situation that is something that you've encountered or something that you are just thinking about. It doesn't have to be specific to login or octalogs. And we can dive into like some cool detections we might be able to write from the logs. If you have ideas, you can drop them in the chat, and yeah. Tammy, to answer your question, some examples of automated responses is let's say you detect that a user is doing something that requires privileged access and they're not in like an engineering group or an SRE group. So maybe you want to proactively message them and ask them to confirm their behavior and provide that result or the outcome to the person who's on call. Or maybe you want the detection detects a pattern that is equivalent to an account being compromised. So you want to automatically suspend that employee account and then provide that result to the on-call responder. And this is helpful because when you're doing response, you're not always looking at everything that's coming in immediately. And if you have an automated response, let's say to like remove access or suspend a user, then there's no gap time in between when that event was detected and when action was taken. Whereas if you wait for a human, one, it'll be cumbersome on them, and then two, it'll take a lot longer to prevent whatever bad actor you've detected. I'm going to share the log examples if people want to open it up. Yes, the threat detections must be very precise if you're going to use automation. Or you can use automation that's less intense, right? That might be just about enriching information or reaching out to the user, sending an email, things that don't take decisive action that could limit a user's things that they could do for their job. But if you're 100% sure it's an IP address is associated with a threat that is attacking your company, then it's better to be safe than sorry and immediately suspend or remove access for a user account. So those are scenarios where you can kind of be very deliberate about the automation you do versus just providing extra information for the on-call person who's responding to the alert. So this is the logs again. I'm going to scroll down to the sample logs that I provided. These are also various types of authentication login logs from Okta. I'll walk through a couple of the things I look for. People have questions or ideas, feel free to put them in the chat. We can walk through some of them. So when I'm looking at one of these logs, the event type is incredibly important, right? Because that tells you how they logged in. If they were successful, you can say event type and the outcome. You can use those together. Sometimes the event types, in this case, show if it was successful, if it was failed. So you can spend time into thinking okay, for this event that happened, what things would be something that I would consider malicious or abnormal that I would want to look further into. So for example, the first thing I always look at is IP address. So you can see Okta gives you some geographical context, but it's an IP address from Texas. So that's not a concern to me. We have an office in Texas. A lot of companies have employees all over the US that work remotely. For me, I would take this IP and I would think, is there known threats that this IP address is associated to? Is it associated to a VPN or a proxy? And based on those results, maybe I would write a detection saying, hey, there was a login event where someone successfully logged in and the IP address is tied to a proxy. We don't allow proxies. So maybe first I would decide to write the detection, and then I might want to look at a historical period where I would look over time to see if this is usual behavior, if this is a new proxy they're using or it's a proxy they've always been using, to kind of understand, is this something new that I need to that needs to be looked into? Is this common? And then based on that, I would be able to write a detection and possibly automation actions that can all be chained together. So every time a new proxy is used by an employee, maybe if that employee is in an engineering group, so they have access to privileged systems, then I would want an alert versus maybe they're a proxy, but they are in a job function where they can't really access any sensitive resources. And that's something I don't consider like high priority. Therefore, I wouldn't write a detection for it. And these are just complete examples of things that I'm just thinking about when I look at the logs, and different ways that you can kind of like poke at them to understand what things you can look at when you're writing detection logic. Sarah said MFA failures. Yes, that is a great one. Also, if you have a log for every time someone uses a multi-factor authentication type, you can look if they're using their phone, if they're using a soft token, if they're using a hard token key, and you can also determine like threat or like severity based on that, right? Maybe you're a company that only allows hard tokens, or maybe you don't have anyone that uses hard tokens. So then the use of one of those would be something that could be abnormal behavior that you would want to look more into and determine if that could be potentially malicious. Carrie said it's also important to understand what your CSP logs. I actually am not sure what CSP stands for in this case. For example, Okta will log the first several failures of a brute force attack, but drop subsequent ones to keep from bloating the logs, but it doesn't mean the attempt stopped. Yes, that is very important. Every SaaS provider or cloud service provider has incredibly different ways of logging things. And that's the part where the research you can really dig deep, and it can take a long time. And working with account executives and the people who maybe run the system in IT. So maybe like you want to look like in Carrie's example, you're alerting on 10 failed login attempts, but maybe Okta drops it after 5. So that in that case, your alert logic or detection logic would never actually generate an alert, which is again why testing is really, really important if it's possible. I'll stop talking for a second to see if anyone else has ideas or things they want to bring up. I'll leave it to folks to determine if they want to try to use the Sigma template that I provided to write some detection logic on anything that involves Okta logs. If it's of interest, then I would love to hear what you come up with. We could share, and I'm happy to take a look at it too, whether it's now or when we finish up the talk. Okay, it's a bit quiet. If people think of things, please put them in the chat. I'm keeping an eye on it, but I'll move forward for now. So one of the things, Carrie asked, have you had any experience with alerting from user-reported behavior? Trying to interpret this. So do you mean alerts that employees have given us? For example, you get an email saying the user reported they didn't recognize a login. Okay, so I think we have seen this sometimes with Okta. So if someone like logs in, it'll send the user an email saying, hey, we've just noticed the login from this IP address, this location. I think, Carrie, that's what you're talking about. And then the employee reports it and says, I didn't log in from there. Can you take a further look? Yeah, okay. I can talk about that a little bit. So there's actually an Okta event type. I don't know if Okta is a system you're thinking about. Some events or some systems do have this event type where they register a new device notification. So you can actually look in logs and determine what IP addresses or what user agents people are usually coming from. Okta also tracks the operating system, which I know some other SaaS providers also. So they'll register if it's a Windows, a Mac, the version, and then you can reference over time. You can look back and say like, okay, well, a week ago they've only been logging in from this IP address. So you could write a detection rule that looks over a series of time to determine if the operating system differs, if the IP address differs, and Okta has sent a new device notification email, that event type occurs, then you could create an alert. So in that case, you should be able to get a alert before, or at the same time the employee is getting that email sent to them where they get the new device notification. If you don't use Okta, I think it depends a little bit on your logging. You can be kind of creative and start like trying to reference every login that differs from logins that are a baseline for you, whether that's like you want to like reference a week ago or you want to keep a cache of employees login behavior and compare to it. Those are options, but personally, like on our end, we use Okta, so we look at that new device notification event type that that always occurs before Okta, which is it's the event that triggers Okta to send that email to users. Rachel asks, are there other indications you see from automated attack tools that alert you of suspicious behavior? Could you elaborate more on automated attack tools? Also, Carrie, let me know if I did not answer your question at all the way you intended it. You can rephrase and I can try and answer it again. Okay, so Rachel said anything to use to brute force, impersonate, etc. So for automated attack tools, I'm thinking you're referencing like a third-party tool. And so in that case, try to think of, we do use some third-party tools that look at like email. We use like some of our own Cloudflare security products. So for example, Cloudflare Gateway is basically it can be an endpoint client or like just forwarded to people's DNS resolve as a DNS resolver for employees that then can do like content and domain blocking and such. So we have rules set up within Cloudflare Gateway, and they could alert us of people going to typo squatting domains, phishing domains, or a rise in those type of domains that are targeting us. And then we can use those indicators of compromise to then write internal detection rules. So we know that if they got past those like third-party block lists or preventions that we have in place, that we can then detect them. So they're like a second layer of defense. Generally, even if we like block a malicious domain or if we have a behavior that is being blocked by a third-party tool, we'll still try to write an internal detection. So that way we know if for some reason a configuration change, somehow like someone slipped by that, we would still be able to detect on that indicator of compromise internally. So we want to like not just rely on those third-party tools, but we do use them sometimes. And several of them have like some like attack information they'll send us if they think something's happening to our organization. Hopefully that answers it a little bit. So I want to touch on like sorry, just answering Carrie's question, follow up real quick. She said it's actually what we ended up doing for new MFA enrollment. Just wondered if there was anything better. User feedback produces false positives often for us, maybe because they don't really understand what the email is. Yeah, that definitely happens for us as well. I don't think there's a perfect way when you have employees involved, because no matter how many times you talk about something, a change that you're making, employees are going to report it as a security incident. So I don't have the perfect solution there. I wish I did. Okay, to jump back into different complexities that you'll encounter. So as you're writing detection rules, obviously you're thinking about the baselines first. Very simple things such as like hash values or IP addresses or domain names that you really want to spend time looking at and researching and preventing or detecting if an action or event type occurs that contains those. But as you get that baseline down, you start spending time thinking about some of the more challenging or complex detections. And that's when you'll start utilizing more of the composite or multiple event detection writing and considering machine learning models. And so I just wanted to put this famous detection and response pyramid on here called the pyramid of pain. Whereas as you go up in writing security detections, they become more and more difficult and challenging and annoying. And you have to think of like new solutions to be able to detect them. So most organizations are on like the first 3 levels where they're really focusing on getting the basic stuff out of the way and writing things that prevent like those initial access attacks. However, once you get those done, you can start moving on to some of the more like complex detection writing. And it takes a lot more research and more specialization and knowledge and understanding your own network and systems to be able to write those kind of more advanced logic statements. I also wanted to touch quickly on what detections can't do. And so they cannot detect all security incidents before they happen. I think some people think that if you have a detection writing team, that they should be able to proactively detect every security incident. That's not true. The nature of security incidents often are very ambiguous, and you can't detect on user behavior that occurs outside of company systems. Someone shares something or is phished on their personal email and then gets access to their personal computer, and person ended up being able to, the employee ended up using their personal laptop for company resources, and the person gets company resources. Those are types of things you really just can't proactively detect. So detections give you a good baseline, so they should be able to alert you on red flags of things that are probably security incidents or at least malicious behavior for you to be able to then further investigate and act on. But you'll never get to the point where you don't have to rely on your employees at all, and you're always writing detections that detect everything you need to know. At the end of the day, like employees are where you're going to get your most weird and ambiguous and interesting security incidents that need to be handled. And those behaviors are often way too complex for any security model to be able to detect. They're also only as good as the researcher who built them. Not to diss on myself or any other person who writes detections, but they're one person's work, and so they should always be looked at as they can be improved, and they need to be changed as systems changed, and they're not always going to detect every variation of every attack. It really takes a team to write detections that cover a lot of scenarios. And that's when peer feedback and working with other people is really, really vital. And even then, they won't be perfect. So you should just anticipate that they're like code like anything else, and no code is perfect. So I wanted to pause one more time for some questions. I see Wendy asked, are there any script hubs where detection code is shared? Yes, there are a couple open source GitHub projects where people share. It also depends on what type of detection code you're looking at. So if you use a Sigma format, there's open source GitHubs. Elastic has shared some. There's pretty sure it's called SOC Prime, is a online sharing platform of different detections written in Sigma format. And they also have a format translator that will take Sigma rules and translate it into like proprietary languages. So if you use Splunk or if you use, excuse me, another SIM, you can try to transfer it. For Snort and Yara, there are quite a few open source hubs that are available that are updated by security researchers in the community. And then a lot of proprietary SIMs will come with a lot of these detection logics already built, or they'll be able to sell them to you. And they have security detection writers in-house that work on that, and they sell it as a product. So depending on your environment is kind of depending on where you're going to get them. Like, are you going to have a detection team that's going to write them for you? Do you only want to write one-off ones, and then you want to purchase other ones from your SIM provider? It just honestly depends on your department. I will say generally the answer to the question is yes, there are some available on GitHub and some other resources. At the end of the day, though, a lot of them are not as helpful as you might think because everyone's environment is incredibly unique. So you might be able to get like the brute force attempt or like brute force attempt type detections and be able to implement them easily into any environment. But once you start thinking about how your own internal environment is used and what like logs you ingest, then it kind of changes a lot of things. So that's the short answer and the long answer. Okay, if there's any other questions, I'm going to move on a little bit, but feel free to drop them in the chat. I want to talk about integration. And by this, I'm focusing on integrating your detections into the greater team that you work on, the greater incident response lifecycle. So detections are just one part of this greater process that occurs whenever there's a security incident. So if you're writing security detections, you're probably in like the first two sections. So you're planning, you're writing the detection, and then you're at the point where you kind of walk away from it. However, if you're on the detection response side or the incident response side, you have all of the rest of the incident response and recovery cycle to go through. So when you're writing a detection, you really want to think about the impact that it's going to have on the person who's responding to the alert. So whether that's yourself because you're on a team that does both functions, or if you are just on the incident response team and you're getting in all these alerts. So the detection may fire anywhere from like 1 alert a month to like maybe it like sends 10 alerts in a day. And then once you get that, you're in charge of analyzing what's happening, understanding what you need to do for the response, containing any potential threat, eradicating it, recovering the system, and then doing any like post-incident follow-up. And so if you're an incident responder, you get the bulk of this work. So as a detection writer, you want to make sure that the work you're doing is valuable to the person who's actually going to be using it. So the person who responds to that alert. Is there enough context for your detection? Do you have documentation for it? Is it noisy? Is it providing actual value to the person who's responding on call? Or is it detecting a behavior that is not malicious at all and occurs quite often and is not at all useful for people who are doing incident response? So a lot of people like to find like fun, like abnormal things in logs and write a detection for it. However, at the end of the day, if that detection is actually not providing any value from a security standpoint to the incident response folks, it's a detection that should be put back into testing or deprecated or reconsidered because that's taking up their time and preventing them from focusing on security incidents that are actually occurring and things they actually need to be looking in that could be real indicators of compromise. As I hinted to like throughout my presentation, having a ton of alerts be passed on to the incident responders is incredibly dangerous because the more alerts you create through your detections, you only have so much bandwidth for the size of your team. Those alerts are either going to be ignored or just not investigated because they have too many other things going on. So even though you think something might be really, really important to look at, you want to make sure that you're not overwhelming your team and then essentially making all of your other alerts also ignored or not worth their attention. On-call analysts will investigate a bunch of alerts, and if they don't actually signal a security incident, your analysts will want to quit and feel they are overwhelmed and burnt out, and they're not actually doing anything that has security value. Helpful alerts are sometimes viewed as the same as older or noisy ones. So if you have 2 good detections running and then you introduce a third that is incredibly noisy, your analysts will just begin to ignore all of them. And even the important ones kind of get put in the backlog. So again, you want to make sure that you're bringing value and you're detecting things that can be realistically responded to by the people who are on call. And so if you fall into this danger of having way too many alerts, then at the end of the day, your detection engineering is ignored. And if you're working all day, every day on detection engineering, you really don't want to be at the point where none of the work that you're doing is actually used because they just don't have the bandwidth to work on something that's so noisy. So this is when I want to stop. That was the end of my spiel on just detection writing in general and different threat scenarios and kind of the way that I work through it. I have a slide with resources that I will put up in a second, but I wanted to see if anyone had any questions about things I talked about myself or security engineering in general that I can maybe answer. Wendy said, I'm curious how you learned what you know. I'm new to IT security and have IT audit experience, but wondering how you got to this point. That's a good question. So things I didn't mention about my background is that I was focusing on history in my undergraduate. And then I also added computer science when I realized I was interested in security. Because of my interest in history, I spent a lot of time doing analysis in textbooks. And it's something that I find like really, really fun. So as soon as I got into the security world, I started just focusing on how can I merge those two. I ended up doing several internships while I was an undergrad, including an internship at Cloudflare on the team that I'm currently full-time. So I worked for a summer. I was able to work on detection writing and kind of, get better at it, kind of understand it more. And once I did, I realized it was something that I really enjoy and that I want to do full-time, like for the foreseeable future. So once I figured that out, I spent like a lot of time reading about it, a lot of time thinking about it. There's a bunch of blogs where people are kind of thinking about the role of detection engineering in security teams, how important it is, what size, what type of companies write detections, and what type of threats they're thinking about. So I spent a lot of time reading a lot of blogs, a lot of time listening to conference talks. And then on top of that, I started full-time in a detection and response role. So since then, I've been able to spend, a portion of my day every day thinking about detection work, looking into logs, just spending time going really in depth into it and thinking about the implications of the detections I'm writing and the systems I'm trying to fit the detections for. And then obviously the other best experience you can get for kind of thinking about how to write security detections is by working in incident response, because you see the incidents that occur that either could be detected through a security detection or incidents that could not be. And what's the difference in why and in what scenarios a security detection can help with incident response, because they're very like closely connected, right? And so I spend 2 to 3 weeks a quarter on call. And in that time, I'm able to like, if I wrote a bad detection, then it's something that I have to live with because I'm a person on call. And it gives you kind of the experience of being in the other person's shoes. So you get both time to spend looking into detection writing, and then also time responding to those alerts and understanding if there's actual value that's being brought by the detections. Hopefully that answers your question. Rachel asked, do you guys ever work with other teams to simulate attacks and write rules based on that? We don't really work with teams inside the greater security department, but we do have people, we'll hire pen testers and then use those findings to evaluate our posture and see if there's security detections we can write based on the actions they were able to take. We also are able to, because Cloudflare produces security products, we're able to give input to the product teams on things that we think they should write detections for, or things they should be alerting customers on. That part is still kind of like in its infancy because, Cloudflare is still growing, but rather than them having input for us and us working with them, or them working with us, we can work with them on some of that stuff, which is interesting. But I would say to your general question, we don't really do like attack simulations internally that often. We do it every once in a while, but mostly we will hire like external pen testing, and then if there's good findings based on that, then we'll use that for detection writing. Yeah, you're welcome, Rachel. Thanks for everyone for attending. While I wait for some other questions, I'll put up the resources slide that I put together. These are some of like my favorite articles that have been written about detection engineering, writing security alerting, and how to think about them. I highly recommend all of these. And I'll post the slide link and the code sharing links in the Day of Security Slack group. So if people are interested in going back and clicking these links instead of having to Google the titles, you're more than welcome to do that as well. And then the last thing I'll say is thank you for everyone who came. Again, I'll stick around for additional questions, but I just wanted to plug that we are hiring on our security team. So if you're interested in working at Cloudflare and you're in the US or Europe, or you're interested in living in the US or Europe, please check out our open roles. And if there's any students out there, we have a open security engineering internship for the summer that we're still hiring for. So please take a look and reach out to me if you have any question about the roles. Susan asks, what are some common oopsies that people or yourself have made when writing detection rules? This is a good question. I would say some common pitfalls is you think that a detection is going to be really low noise. So you find an event that it's occurring and you think that's an event that we should, the on-call people should look into, make sure that's not malicious behavior. And when you test it, it maybe generates like one alert a day. And you're like, okay, that's something that's definitely manageable. And then for some reason, the user base changes or something is changed by IT, or there's some change in the system and you start getting a ton of alerts. And so then you need to think about, okay, well, the logic I wrote is something that I think is valuable, but now the on-call people are getting slaughtered with alerts. So how can I either automate some of the process away or make the detection logic more granular so that they're not getting swamped with alerts? And I think that's something that that is just a constant changing thing within companies. A detection wrote a rule that you wrote a year ago. There might be something that's changed and it's no longer useful, or it needs to be rewritten to be useful, or there needs to be automation steps added. And that's kind of part of just detection engineering, being always able to look at it, understand that it needs to be rewritten for the new use case and changing it. Also, Sarah asked if the slide links can be posted here. I will post them in the chat in a minute. But if people are also on the Slack, they'll be available there as well. Any other questions I can answer for folks? Well, if not, I'm posting the slides in the chat. I'm really grateful for everyone who came and asked questions. I really appreciate it. I hope you are interested in learning more about security detection work. If you have any follow-up questions that you think of later, feel free to reach out to me on the Day of Security Slack group or on LinkedIn or however you find me. But yeah, thanks again to everyone who attended.